and welcome to this session of information retrieval. Today I'm going to start discussing something very interesting. This story is from the book The World of Mathematics, Volume 4, titled as The Law from Robert Coates. The World of Mathematics. People say those who read this book fall in love with mathematics. And boy, that's really true. I'm one of them who has fallen in love with mathematics uh, ever since I have read this book. Uh, the story goes as follows. On one fine day in the late 1940s, this is New York, uh, the author says, no other bridge or main highway was affected. And though the two preceding nights had been equally balmy and moonlit, on both of these, the bridge traffic had run close to normal. And then one day, it just looked as if everybody in Manhattan who owned a car had decided to drive out to Long Island that evening. Nobody could understand why this is happening. So the sergeant would ask, and even the toll booth operators would ask all the drivers, uh, is there night football somewhere that we don't know about? Or is it the races that you are going to? But the funny thing was, half the time they would be asking them back the same question. What's the crowd for, Mac? They would say. And I would just look at them, said the sergeant. The point is, if normal things stop happening, if we lose regularities in our life, our planet could become unlivable. So people were really concerned. This act was on the newspaper the very next day, and Congress was called for an action. Senator said, you can control it. Re-education and reforms were decided upon. He said, we need to lead people back to the basic regularities, the homely averageness of the American way of life. So here I present to you people the law of large numbers. So this is a very interesting find which uh, applies to us in so many walks of life. It is also known as the fundamental theorem of probability. It says the average of the results obtained from a large number of trials should be close to the expected value and will tend to become more closer as more trials are performed. Here's an example. If you roll a dice, assume you may see 1 to 6 with equal probability, then what is the expected value? Pause the video here, take a minute and work it out yourself. Right. So the expected value is simply 1 plus 2 plus 3, the sum of all possibilities over the universe, which is 6. So we get 3.5. So what does this mean? According to the law of large numbers, if a large number of six-sided dice are rolled, or if a six-sided dice is rolled large number of times, the average of their values, sometimes called the sample mean, is likely to be close to 3.5, with the precision increasing as more dice are rolled. A minor digression here. Uh, do you remember the fundamental theorem of algebra? Yes, we have one fundamental theorem there as well. Well, very loosely put, it simply says every polynomial has roots, and more precisely, every non-constant single variable polynomial with complex coefficients has at least one complex root.